Voyager's final transmission, what we discovered at the edge of our solar system. In 1977, two spacecraft launched into the unknown. Small, silent, and slow by today's standards, Voyager 1 and Voyager 2 weren't meant to last more than 5 years. They were built to observe the gas giants, send back a few photos, and then fade into the void. They didn't. More than 45 years later, both Voyagers are still out there, alone, cold, drifting through a realm no human eye has ever seen. And just when the world assumed their time was up, they began transmitting the strangest, most haunting discoveries humanity has ever received from space. This isn't just a story about spacecraft. It's a message about what exists beyond the borders of our solar system and what lies ahead for those brave enough to explore it. 1. A signal from the void. Voyager falls silent. In late 2023, Voyager 1 fell silent. For months, it sent back nothing but a meaningless stream of binary data. The world feared the worst. The furthest human-made object had finally died. But NASA's team refused to give up. After months of careful commands sent across more than 15 billion miles and 45 hours of radio silence for each round trip, Voyager 1 came back online in April 2024. It was a miracle of engineering, a triumph of perseverance, and also a reminder that this tiny traveler still had secrets left to share with us. Silent but not forgotten, still alive against all odds. Its revival not only renewed faith in human ingenuity, but reminded us how even the quietest machines can still echo across the coldest, darkest corners of the cosmos. The grand tour, how it all began. Voyager's journey began with a rare planetary alignment that occurs once every 175 years. This allowed the spacecraft to use gravitational slingshots to visit multiple outer planets in one trip. Voyager 1 flew by Jupiter and Saturn, sacrificing a longer journey to get a close-up of Titan, Saturn's mysterious moon. Voyager 2 took the extended route, becoming the only spacecraft ever to visit Uranus and Neptune. They revealed Jupiter's previously unknown ring system, the cracked, icy surface of Europa, sparking theories of a subsurface ocean, active volcanoes on Io, the first time volcanism was seen beyond Earth, Neptune's blue storms and Triton's icy geysers, Titan's thick atmosphere, capable of harboring alien chemistry. This wasn't just exploration, it was redefinition. Entering the unknown, the heliopause. By 2012, Voyager 1 crossed the heliopause, the invisible boundary where the sun's solar wind stops and interstellar space begins. Voyager 2 followed in 2018. What they discovered there challenged everything scientists believed. The solar wind doesn't fade, it stops abruptly. Beyond it lies a denser, colder plasma, the true medium of interstellar space. Magnetic fields are 2 to 3 times stronger than expected. Interstellar pressure is 10 times higher than previously estimated. Instead of a smooth transition, the edge of our solar system is a turbulent boundary, a wrinkled, shifting skin that separates us from the rest of the galaxy. The interstellar shock, a cosmic anomaly. At more than 18 billion kilometers from the sun, Voyager 2 made a bizarre discovery. Space beyond the heliopause wasn't empty. It was denser than anything scientists predicted. Scientists expected approximately 0.037 particles per cubic centimeter. Voyager 2 recorded 0.12 particles, 3 times higher than theory. The probe's data forced scientists to reimagine what interstellar space might contain and what pressures might be shaping it. Why is space getting denser? Are we approaching a cloud, a magnetic shell, a galactic wall? No one knows. But clearly, interstellar space isn't the calm void we once imagined it to be. It's a dynamic, shifting environment full of strange, hidden structures. These findings challenge long-held models of the interstellar medium and raise new possibilities about what surrounds us. Layers of unseen forces stretching across billions of miles. 5. The hum, a message from the deep. In 2020, Voyager 1 picked up something strange, a steady low-frequency hum from space. It held constant at 3 kilohertz for over 3 years. Even as the probe flew further, the hum remained unchanged. Scientists believe it's plasma waves, interstellar gas vibrating like a musical note. But some wonder, why is it so stable? Why hasn't it faded? Could there be an unknown energy source out there, broadcasting a signal in all directions? Even if it's natural, it's unlike anything we've ever heard from the universe. 6. The local bubble, our galactic safe zone. Back on Earth, astrophysicists discovered something equally stunning. The sun isn't drifting through open space. It sits inside a vast structure called the local bubble, an invisible 1,000 light-year wide void in the galaxy. Formed by a chain of ancient supernova, this bubble surrounds surrounds us with low-density gas and is expanding steadily outward. Thanks to Voyager data, scientists now believe the local bubble influences how stars form around us and may act as a protective barrier against harsh galactic radiation and cosmic debris, effectively insulating our system within a quiet galactic neighborhood. Without the shielding of this bubble, cosmic radiation levels would be far more intense, suggesting our very evolution may have been shaped by this rare pocket of space. 7. The pale blue dot, humanity's most distant self-portrait. In 1990, before its cameras shut down forever, Voyager 1 turned to look back. From 3.7 billion miles away, it took a final image. Earth, a single pale blue pixel, floating in the dark. That photo inspired Carl Sagan's famous words, "That's home, that's us." Today, as Voyager drifts beyond the influence of the sun, that image takes on new meaning, a memory from a traveler that's still whispering across time. 8. The gold records, humanity's message to the stars. Both Voyagers carry something no other spacecraft has, a golden record encoded with greetings in 55 languages, music from Beethoven to Senegalese drumming, images of human life, DNA, animals, and math, the sound of a mother's kiss and of a baby's first cry. Designed by Carl Sagan's team, these records are a cosmic time capsule, a whisper to anyone or anything that may one day find them. If found, they may outlive Earth itself. 9. How long can Voyager survive? Voyager 1 is nearly 16 billion miles away. Voyager 2 trails at about 12.5 billion. Their power is fading. By 2025, most instruments will shut down. Soon after, the antennas will fall silent forever, lost to distance and time. They'll continue coasting through the stars, carrying their gold discs, silent emissaries of Earth, for billions of years to come. Even if we lose contact, they've already made history. They're our most distant ambassadors, and they've given us a view of space and ourselves that no other mission ever has, a legacy of humanity etched into the fabric of the cosmos. They will likely outlive our civilizations, our languages, and perhaps even our planet, drifting quietly long after we're gone, like ancient scrolls on a cosmic current. 10. What comes after Voyager? NASA and other agencies are now designing interstellar probe missions, new spacecraft that could travel 10 times farther than Voyager. These probes may push the boundaries of exploration beyond even our current imagination. Equipped with updated sensors, fusion-powered engines, and perhaps AI, these craft may one day map the true shape of our solar system, detect strange forces in interstellar weather, and even identify the chemical fingerprints of alien worlds. But Voyager will always be first. The first to leave, the first to hear, the first to whisper back, and the first to dream across the galaxy for us all. And though future probes may travel farther, none will ever carry the same wonder, the feeling of stepping into darkness before anyone knew what was truly out there. The Voyagers began as simple explorers, but they became something much more. Messengers from Earth, pioneers of the unknown, and mirrors of our greatest questions. They've shown us volcanic moons, hydrogen oceans, cosmic bubbles, galactic storms, and the hum of something waiting in the dark. Whether that hum is natural or artificial, random or intentional, one truth is clear: we've only just begun to listen. If you found this story as fascinating as we did, be sure to like, comment, and subscribe for more mind-expanding explorations into space, science, and the future of humanity. Because while the Voyagers may be drifting through the stars, their journey reminds us that our own adventure is just beginning.